What is going on, y'all? It is your girl Alana, aka Tech Girl Magic, and today we are going to be working through the Roman to integer solutions. I'm going to be talking about 3 different ways that you can solve this problem, and at the end we'll wrap up with a code walkthrough. So if that is what you are looking for today in your study session, then you are in the right place. Before we get started, just a quick reminder that if you find this video helpful, please make sure to like and subscribe. It really honestly just gives me the motivation to keep doing these videos and lets me know that you're enjoying the content. So with that, we'll go ahead and dive right in. First, we'll talk about the problem statement, and then from there, we'll go through a couple clarifying examples to build some initial intuition. After that, we'll go through the first kind of brute force solution that you might imagine with a problem like this, and then we'll build on top of that with some more approaches and then kind of wrap up. So let's move over here and talk about the problem statement. It says Roman numerals are represented by 7 different symbols. Uh, then it has the symbols here, and it looks like it has their mapping as well. For example, 2 is written as II in Roman numeral. 12 is written as XII, which is simply X plus II. And then it has kind of this other example for how this number can be written, how 27 can be written. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not I. Instead, the number 4 is written as IV. Because 1 is before 5, we subtract it, making 4. The same principle applies to the number 9, which is written as IX. And then there are 6 instances where subtraction is used here. And then it goes through kind of these instances. And then finally, after long last, it says, given a Roman numeral, convert it to an integer. And then we have kind of, at the bottom here, we have some constraints. It says that the string length can be between 1 to the number 15. And then our string can only contain the characters that are correct characters for Roman numerals, and that it's guaranteed that S is a valid Roman numeral in the range of 1 to 3,999. So, okay, so let's talk about this. So I don't know about you, but I definitely would look at a problem like this and probably just kind of glaze over it. Like my eyes would just go like real like jelly donut here. But I think it's really important for problems like these to try to just take a deep breath. When you see kind of this wall of text, take a deep breath and read through it again and see if you can kind of piece together some of the most important aspects of the problem, especially when they're telling you about how we usually do stuff, or the right way to do stuff, or whatever, right? So with that in mind, let's actually look at this and say, what is the most important parts of this problem statement? First off, uh, it says that Roman numerals are usually written largest to smallest from left to right. However, there are 6 instances where subtraction is used. And then it kind of gives these instances. So here, right off the bat, this is going to be super important because it's letting us know that in the majority of our cases, kind of in our code, when we talk about the main case or the main logic, we're going to want to be making sure that this is holding true, right? That Roman numerals are written from largest to smallest whenever we're doing this kind of conversion from a Roman numeral to an integer. And then basically here, it kind of explicitly tells us some edge cases that we also are going to want to account for in our code. So kind of these edge cases where basically if you have a smaller number right before a larger number, we're going to have to do some kind of subtraction here. We're going to have to take care of the subtraction edge case. So that is, after you take that deep breath and, you kind of pull yourself together after reading that long problem statement, that's kind of how I might first approach tackling this sort of problem. From here, we can look at the constraints and we can see that the constraints tell us that S is actually not going to be some random input, or some random length input. S is only going to be length input 1 to 15. And these are very finite numbers. This isn't like, you know, negative infinity to positive infinity. This is a very finite, tangible number. So this is also kind of, you know, be kind of key a little bit later on when we're talking about what is the big O of this problem. So from there, let's actually dive right into the clarifying examples. So initially, let's look at this this Roman string x v I. So we can basically kind of create this like mapping that they give us in the problem, and take each one of these symbols and just cross-reference it with the map. So all right, x, what's the value of x? The value of x is 10. So we're just gonna, you know, mark that down. We'll keep going. What's the value of v? The value of v is 5, etc. We just keep going through the string, and we kind of, from this point, can see that each one of these numbers is one after the other getting smaller and smaller. And this is what is following that kind of, you know, usual case, right? The numbers are going from highest to lowest. And with that in mind, we can kind of just simply add these numbers. There's no edge cases here. There's nothing else that we have to worry about. And we see that this number actually ends up adding up to 16. So from here, let's actually do another example. So we're going to look at xiv and see what goes down. Again, we're going to look at our mapping right here, and we're going to connect that x to 10. We're going to keep on chugging through the string and just kind of convert it using our mapping that we've created here on the side. And we see that this particular ordering of numbers is not going from highest to lowest. We have this like exception case here, the subtraction case here. And we can identify this subtraction case because we see that the number right after it is larger than this number. 5 is larger than 1, right? 1 is not greater than 5. So with that, we know that we are going to have to do some kind of subtraction here in order for us to get the right number, which in this case is 14. Even though it was the same symbols, it ended up being a different number. So that's going to build some kind of base intuition here, and we're going to get down even further and really start cracking down on the logic that we're going to need, and then at some point towards the end, the code, right, that we're going to need to solve this problem. So with that, let's kind of go through our brute force approach. So we're going to establish our example string here. We have our indices, and right off the bat, we're going to establish our state. In this particular case, we're imagining our state as a map. So if you're working in like Python, JavaScript, it's fairly easy to create a map with those programming languages, actually quite trivial. So you can kind of create that right off the bat. If you're working with a language that's maybe like C++ or Java, where it's like maybe a little bit extra work to create a map, you can also imagine this as like a function with some if statements or like a switch statement. We can kind of get away with that here because we have a finite number of symbols that we're tracking. And so you'll see in the solutions that I have linked in the description below that in some of the actual code solutions that I did for this particular problem, that's an approach that I took. But most important here is whenever we're looking at a problem like this, let's establish our state. From here, after we have our state, we can start to work through the problem. So we're going to establish a value total, which is equal to 0, and then we'll establish a pointer. This can be in like a while loop or a for loop, but we'll establish our pointer and start looking at the very first index, the 0th index. So we'll look at C, and we're going to cross-reference this with our map right here. We're going to cross-reference the value of C with our map value, and we'll ask ourselves, okay, is this, am I looking at like a subtraction case here, right? Like, is this current number, is the value of this current number less than my next number? And then from there, if it is, then we know that we're going to have to take the difference and then add that to total. And then if it's not, then we can just simply add that single number to total. And we don't have to worry about any subtraction at all. So coming back here, we'll say, okay, C is 100. We'll take a peek. We'll look at our pointer and we'll plus 1 from our pointer, and we'll look at the number 1 index and say, okay, is this number greater than my pointer, or is it less than my pointer? In this particular case, we have that C is 100 and X is 10. So C is greater. And all we have to do in that case, it's kind of our main case. All we have to do is just add that to total up there, right? And so we kind of tackle our very first step, and we can move on from there. So we'll move on, we'll go to X, and we'll do the same exact thing. We're gonna take that peak, we're gonna +1 our pointer, and now we're looking at the index number 2. And we'll say, okay, is the value of this symbol according to our map, is it greater than or less than X? In this particular case, L is 50 and X is 10. So this is an edge case. And we've identified that's an edge case because we see that our kind of next number here is greater than the number that we're looking at. So at that point, we can just do our subtraction, and whatever the value that comes out of our subtraction is, we'll add that to our total and we'll move on. And in this particular case, this subtraction case, not only will we move on, but we're gonna move on by now adding 2 to our index instead of 1, because we don't wanna like double count L. We've already processed L. So we're going on to the last index now. Again, we would wanna check to see, is the next index greater than or less than this particular value, but we see that we're at the end. We don't actually have anything to check. And so we don't ever have to worry about, the subtraction case for this particular indice, the last one. We just know that all we have to do is just add it. So we'll just add that to our total, and we see that our total is 141. So at this point, I think it's so important that I remind everybody that today's study session is brought to you by Wealthfront. One of the main motivations that I have to start this channel is to not only help you get into tech, but also to help you build wealth and kind of change the trajectory of your life with the money that you make in tech. And the very first step to that journey is going to be to invest with Wealthfront. So if you use the link down in the description below, you will be able to get up to $5,000 of your money managed for free. I think it's a pretty sweet deal. Wealthfront is one of my favorite apps, so go ahead and check that out below. So now with that out of the way, we will walk through the pseudocode here and kind of explain it, and then keep going with the rest of our approaches and kind of deeply understanding this problem. So first, we are going to establish our state. Right off the bat, for a lot of these problems, it's very important. Let's just establish our value map, right? Let's establish total is equal to 0. Let's establish I, our pointer, is equal to 0. And from here, we'll say while I is less than the length of string, if I plus 1, this is, kind of those I emojis that we had earlier. If I plus 1 is less than the length of string, then, and if the value of S of I is less than the value of I plus 1, again, our I emojis coming into play again, then we will actually just end up taking the value of I plus 1. We're gonna have that we're gonna subtract the value of S of I from that, and then add that to total here. So this is kind of the difference, right, that we were referring to while we were walking through the prior kind of explanation. And if we're not in this case, then that means that we're in the main case, right? This is kind of our subtraction case. And if we're not here, then we're in the main case, which is just simply to add the value S of I to our total. Okay, and we can return that. And so now we kind of went through all this effort, and we ask ourselves, what is the big O? And the big O of this particular solution is going to be O of 1 time and O of 1 space. And I don't know about you, but when I first saw this, when I was first practicing this when I was younger, I was just absolutely shocked. I was just like mind blown by this, because my thinking was that, all right, well, we have yet another problem where we're given some string input. We're iterating through the entirety of that input, the length of that input. Let's say that the length of that input is n. If that's the case, then this problem is going to be O of n, right? O of n time. But here is the gotcha, right? Or it's not even really a gotcha, because they literally just tell you this. But it's really important here when we're looking at this to say, okay, well, what is the maximum of the length of our string? If we actually look at the constraints of the problem, we see that the maximum length of the string can only ever be 15. You know, for some of these problems, we see that the maximum can be like positive infinity, and the negative or the length can be like negative infinity. For this particular case, you know, length is always going to be a positive number. So, you know, this is kind of typical, but sometimes they're like, hey, the length of this is going to be the maximum length is going to be like 2 to the 10 to the like fifth or some crazy thing. And in that world, then it would make sense that we're going to be dealing with something that's O of n. But because we are only ever given a maximum of 15, you know, O of 15 simplifies to O of 1. And that is why we are dealing with this situation where we're actually just looking at O of 1 space here and not O of n. And the same explanation can be applied to our space. We're only ever keeping track of, like, you know, some finite amount of numbers. In this particular case, 7 or not numbers, but 7 letters, right? 7 Roman numerals. That's never going to grow no matter what the input is, like that's never going to grow. So that's going to be O of 1, and that's why we kind of get this joint big O of O of 1 time O of 1 space. So just really wanted to hone that in because I think that that is just kind of, you know, this is a really great problem to really understand that and really kind of work on that muscle, on that big O muscle, and maybe kind of get out of the habit of just automatically saying something is O of n whenever there's like a for loop or while loop. So it's really, really, it's about what is our input, what's the maximum of our input, is it basically infinity? Okay, well then, you know, that's going to be O of n, right? We're going to be scaling. If we have to iterate through that, that's going to scale. But if the maximum is like 15, then at some point we're gonna easily hit that maximum, and it's basically just O of 1 from there. So kind of okay, with that understanding, let's kind of jump back in here. And typically in these videos, this is where I do my, all right, you know, why is the brute force so slow? Let's, you know, how can we optimize it? And we kind of look into the optimized version. For this particular video, because of literally what I just explained, we're actually just going to go through 2 other approaches on how to solve this problem to really try to get the most out of this particular study session and make sure that we can really deeply understand this material and succeed in our interviews. We're just going to go through 2 more approaches. So we'll go through one approach. It's kind of like a quick tweak to what I just talked about. We'll go through that pseudocode, and then we'll go through kind of a deeper explanation of the right to left approach, and then we'll finish up with the code walkthrough at the end. So we're going to keep rocking here, and we're going to say, okay, another tweak that we could have done to that prior approach is just saying, you know, instead of only having 7 Roman numerals in our state, instead of only saving that, let's just save kind of all of the possible valid Roman numerals in our state. So, you know, we're not only going to save the single or sorry, the length 1 characters, we're also saving this like you know, 2 length characters as well. And if we do this approach, we can establish this idea of taking kind of taking that substring of 2 numbers in this like greedy approach. Excuse me. This greedy approach, and we'll say, okay, if this 2 numbers, if this exists in my value map or kind of my value function, whatever I wrote, if I can find a valid pairing here, then I'll add that to total. Okay, and then if we're not in this case, then we're just kind of in like the normal case, the usual case, which is that our single digit, we're gonna cross-check that against value and add that to our total. So this is kind of a quick iteration of the prior approach. And you know, as usual, all of these, even though I'm walking through pseudocode in this moment, this code is available in the description. And so if you do want to follow along with me here, you can go ahead and grab that code at the link in the description, and you'll kind of see what I'm talking about in the actual code. I think I've code for Python, Java, JavaScript, C++, and C# down there. So, you know, if you're rocking with me, if you're with the Tech Girl fam, go ahead and check that out. And, you know, we can kind of keep it moving here. So with this, you know, we'll return total, and then finally we'll get to this right to left approach. And this particular approach I think is super interesting because it's not, kind of your usual to go reverse. It's not necessarily something that I would kind of knee jerk immediately go to. But whenever you look at these problems, I think it's really good to say, okay, I have this string, and maybe typically I am going to go through it from the beginning to the end. But what could happen if I go through it from the end to the front, right? You always want to be just kind of almost in this like this hacker mindset, this like, I'm going to use any approach that I can to solve this. And so I think it's good to kind of walk through the right to left approach, because it's kind of counter, I think, to a lot of the habits that we can get into this problem, but it's still a valid way to solve it. And for some people, it actually is a lot easier way to understand what we're doing here. So um, we'll walk through this quickly. We'll say, all right, we have this example. We have, our example again. And this time we're going to start at the end. And when we start at the end, we're just going to say, all right, the end, this value, we're just going to set total equal to that ending value. And then from here, we're going to just walk through towards the front of the string. And we're going to walk through the front of the string and kind of peek, at what we just saw. So we're going to take that peek. We're going to use our eye emojis. Here, we're going to look at pointer +1. We're going to say, hey, what is this value? Is this value greater than or less than what I'm currently pointing to? In this particular case, L is greater than I. And so all we have to do then is just add L, right? And then kind of just move on. So then now we're looking at X, and we do that peek, we do that pointer +1 action. And then we say, okay, is X greater than L? The answer is no. Looking at our map here, we see that X is 10, L is 50. So we do that, we do the subtraction of just X, right? Of just X, because we already kind of added L to our total, so we don't have to even worry about that anymore. We just subtract X, as part of our subtraction edge case. Once we do that, we keep chugging. All right, so we're at our 0th index. We take that peek, we do that pointer +1 peek, and then from here, we're gonna say, all right, is this greater than or less than? Turns out it's greater than, so we just add that to our total, and boom, bada bing, bada boom, we're done, right? We're in there, and we pretty much solved the problem as best that we can. We got that O of one time, O of one space action going on, and we're good. So at this point, we kind of walk through all of our solutions here, all of our approaches. I'm going to move on to the code walkthrough. Typically, I actually do the code walkthrough for like the optimized version. Since there isn't one for this particular case, we'll walk through the first approach that I talked about, since I think that's kind of the most approachable approach when you initially kind of get started here. And we'll do that in Python. But again, all the code solutions for everything that I just talked about in the description below. So make sure to grab that. All right, so we are in our IDE, and we'll go ahead and say first, we'll establish our value, our kind of value map. And we'll just quickly kind of enumerate all of the values that we were first given here. But with that established, now we can say total is going to be equal to 0. We established the rest of our state. Once we establish our state, we're going to set up our pointer to kind of walk through our length of our string. And we'll start with the subtraction case. And we're going to say, all right, first here we say I +1, just making sure that we're kind of in bounds here and we don't throw any out of bounds errors. Make sure that when we do this peek, we can actually do it and there's actually a value there. And then once we have that established, we can start to say, all right, what is the value of our pointer, the value at the place of the string that we're currently at? And then what is the value of our peek, right? What's the value of our pointer +1? And if we are in this particular case where we're actually in the subtraction world here for this particular step in our algorithm, then we are going to take the difference and add that difference to total. And then increment our pointer by 2. And so if we're not in this particular case, then we are in the main case. And we can just take the value that our pointer is pointing at in the string, and we can add that to total, and then we will increment our pointer by 1, and then we'll return total at the end. So let's see, how does this go? How are we doing on our first test case? Okay, cool. So that's looking spicy. Let's go ahead and submit this and see what we got. Let's see what we got here. Oh, all right, success. Looking like success, smelling like success. I absolutely love it. So if you found that video helpful, then please, again, make sure to like and subscribe. Thank you so much for your time and attention today. It was an honor to walk you through your study session, and I wish you the best of luck in your studies, and I will see you in the next one.